a week's vacation and where I have been chilling with my grill in, and I'm ready to start making videos again. The problem is that I've sort of been out of the loop for the past week, so I haven't really been paying much attention to the press releases and the news and astronomy in the world of astronomy as closely as I ordinarily would. So this week what I thought I would do is talk about a news announcement that came out back in November of last year. This was before I started making these Space Fan News videos, and since I thought this was incredibly interesting, I would take a minute to discuss this with you and sort of help present it to you. The problem is this is pretty hard stuff, so I don't know. I hope this will make sense to you. So let me begin by giving you some context. This is a picture of the entire universe from every area of the sky. And the photons that made this image have energies that lie in the microwave region of the spectrum, and they were created by the Big Bang. And I'm sure most of you recognize this by now. It's called the cosmic microwave background. Now, it has always been thought that this image, these photons, mark the farthest back in time we would ever see. That this marked the boundary of our observable universe. Now, if we could see beyond this image, that would mean that we're seeing a time before the Big Bang, something that our current model of the universe, known as the standard model, and includes things like dark matter and dark energy, says isn't possible. But that assumption is being challenged, and here's where the announcement comes in. On November 15, 2010, a group of physicists released preliminary findings of what they claim to be evidence of activity prior to the Big Bang. Now, to explain that a little bit, let me give you a little more context. So, it's recently been discovered by the WMAP probes, and more later accurately mapped by the Planck Space Telescope, that there are tiny variations in the temperature of the cosmic microwave background. And you can see it here in this image. The red areas are just a little bit warmer than the blue areas. And these variations represent changes in density in the universe. They're very important. And it was these variations that give the universe its structure, the galaxies and clusters of galaxies that we see today. Now, because of a period known as inflation that occurred just nanoseconds after the Big Bang, these variations are thought to be random. And it's one of the tenets of the currently accepted standard model of cosmology, that these variations be random. Now, paradoxically, despite this randomness, in order for protons, neutrons, and electrons to form in the universe, the early universe must be in a state of low entropy, which clearly is not the case here. There's lots of randomness, but in order for these to form, you have to have some order to this. And the standard model doesn't explain this low entropy state to the universe. So here is where something known as conformal cyclic cosmology comes in. And put as simply as I know how, because I don't fully understand it myself, this says that the early universe was smooth. But even though right now the universe is full of structure with stars and galaxies and black holes everywhere, the cosmos will one day return to being smooth again after all the matter has been consumed by all the black holes in our universe, leaving behind only energy. So this framework predicts that all matter in the universe will eventually be consumed by the black holes which inhabit it, evaporating all matter and leaving a universe of only energy. And this low entropy state will lead, the theory goes, to an era which will trigger another Big Bang. Now, these are very preliminary findings, but they supposedly support this idea. These physicists claim to have discovered what appear to be concentric circles in the cosmic microwave background. And these circles, they believe, are the imprint of gravitational waves resulting from collisions of black holes that existed in a universe preceding ours, a prior universe where all matter had evaporated and only black holes remained. Okay, so that's a pretty controversial claim, and this discovery is not without its distractors, because as is true with all claims like this, they need to be followed up carefully and given more analysis and hopefully more observations. So we really need to be careful about what we conclude from these results. But I did want to share them with you because I thought they were very interesting and certainly bear keeping our eye on it as this story unfolds. So I guess that's it for now, space fans. Thank you for watching, and keep looking up.